So, welcome. My talk is about lean microservices and OSGi. So the idea is to show how you can do microservices without the overhead that current approaches of microservices. So let's see. It's a demulator. So if you have IRC on your machine, you can try to participate. You go free node and this channel OSGi chat. It's not necessary, but it would be. So we start with the typical definition of what microservices. According to Martin Fowler, it's a way of designing software applications as suites of independently deployable services. It's a business capability, auto deployment, intelligence, and decentralized control of languages and data. So to put that in bullet points, you have independently deployable services. You have verticals, like we already heard in the talk before. Decentralized data is very important. If you want to do real services, each microservice must have its own. If you have one central database with one central set of services, you need automated deployment because you have so many processes you want to host. You can't do that by hand. Because it's one service. This is what we see now as average microservices. I will show the approach. And you have lightweight REST. How lightweight that actually is, but they call it as lightweight. So the typical way, or the more prominent way to do microservices is using Spring Boot. Basically, it's a framework that is very suited to this idea of one process per service. It allows you to really start fast. You have the website, you paste some starter, and you're ready to go, and it's already producing something that kind of works. So it's really good to get a POC running and get funding. That's why it's so popular. But also requires innovation and has good cloud support. So on the way quick, but we'll see where the fallacies are. So let's see. So there's the dark side of microservices. Or if we ask Yoda, are microservices stronger than OSGi? So it might be no, quicker, easier, more. This can lead you on a kind of dark path where you're heading in a direction you can't return easily to the light. Like this, microservices, like Steph Tirko puts them, should not call other microservices. That's the theory, but the practice, each microservice is some team and coordinating what they're doing, so they're calling others. If you're lucky, you have this diagram at all. If you're unlucky, you just don't know what happens. But if you call any of these microservices, you don't know if they fails, what parts are part of this failure. So it's really difficult to debug such a system, you can imagine. There's also the operation aspect. So the good old application service, that's something like this. You have your modules, you put them all into your application server, and you steer one big vessel. It's a bit slow, it's a bit not so agile, but at least you have one steering wheel, and it's kind of easy to steer. The theory of microservices is like that. So fully automated harbors where the containers are put on the robots, everything finds its way, it's all fully automated, completely error-free, kind of. Oh, sorry. This is more like it's today. This is how remote islands did the processing of containers. They had no special harbor facilities, so they took what they had, these small barges, and put containers on. So Stocker swarm, and it kind of works. other thing is, like we also did before, microservices cannot fix your design. If your design is not modular at the start, if you take it apart, it's the same. It's just you have more of these. And having more of these heaps make them more pleasant. Microservices with Spring Boot, what's wrong with that? It looks really easy to start in minutes. But look into the maven dependencies, it goes way down. So you see, it drags in a lot of dependencies, and these dependencies are not only at runtime, because at runtime you might need them, but they are also at design time. Every developer has all these dependencies in his Eclipse and can use classes. So how do you tell them what to use, what not? You can just use everything, and they will. So it's difficult to have standards in your coding and limit the libraries you use when you use Spring Boot, because it's all that stuff, and people. And the thing is, microservices like always communicate remote, because Spring Boot has no modularization where you could put services together if you want. And service has to be in this own process, in its own project that is compiled individually, and they cannot be together. And it's all proprietary. So all these annotations from Spring, they are all Spring annotations. So once you go that way, you're all on the Spring path. It's not easy to go back. And it's also not flexible in the package. You know, one deployment unit, one process designed to be. And we heard distributed computing is complex. As an example, a small Spring Boot project not in there can easily align dependencies and 20 megabyte, which is, it uses probably rather more. And all this pollutes your class path, and it's difficult to limit your developers to do something sensible with that. So how is OSGi different? The idea in OSGi is code against APIs and specs. This is what enables the loose coupling. You do that for standard API, but also for your code. Have your APIs, your interface for your services, and you only code. You also have these self-describing modules, the bundles. A bundle tells you what it needs, what it provides, and this allows at the assembly phase to reason about if this set of bundles it can provide the functionality that you want. Without bundles, you just put JavaScript together and keep your fingers crossed to hope they're working. You only know when you call stuff. OSGi services are also really important because bundles can communicate over services by just knowing these. They don't need to know the implementation. And this is kind of a similar connection like between Spring Boot containers, but all in this a lot simpler. Semantic versioning, which I look into later, and remote service admin, also separate slides for that, and how the pitch is done. So semantic versioning. We all know typical versioning schemes of major, minor, bug fix version, but in most applications, they are marketing, so affect anything. But in OSGi, you can have the basing, can do that build, and say, if I change an API in a compatible way, alert me and say, and wait till I get the version to change. So if it detects, I have to increase the major number of package it exports to let the build continue. So I have some automatic checking when I do incompatible changes in my interface. Remote service admin. This is an illustration of the spec. It has several parts in it. Modular. You have service admin part that publishes an OSGi service service as a remote, for example, as a REST endpoint, or creates a proxy for a remote REST endpoint that you can consume as an OSGi service. The topology manager, which manages all the local services and the remote services it finds and decides how to publish or import which of the services. So you can do some policies on that level, like enforcing security, something like that, on kinds of services from the outside. You have flexible discovery, so you can do as a discovery for distributed set of services, but also very different other parts, like, for example, in RS we also have a very simple config-based discovery where it just it action to a remote service without discovery system like in the background. So basically, it allows you to host services which are normally just and allows to do remote communication with these, but also allows to just publish a REST endpoint that others use completely without OSGi. So it also enables you heterogeneous networks. So as an example, if you do REST with a remote service admin, you have a use bundle that publishes an OSGi service, just a class with a component with declarative services and XRS annotations. Topology manager picks that service, selects a suitable transport, for example, the transport with RSA, and this transport creates REST endpoint, which opens the HTTP and delegates to your OSGi service. So your bundle, just the OSGi service, doesn't remote, and the remote service admin implementation takes care of the rest. So how does it look in practice? I've prepared a small chat application. It's a very simple interface. And there are several modules that interface and use it. So, using Apache Camel, which connects to an IRC channel and forwards messages from the channel to our chat system and forwards our messages from the chat system to the IRC channel. This is where you can participate. There's a shell integration with a Go shell. You can send a chat message which is distributed through the system and received message on the shell. There is this Tinkerforge display which also displays chat messages, and there is a motion server where when it's motion, it should send out a message on the chat. So it can be done in one process with OSGi services, or optionally with RSA with remote. So basically, the small system is how you start, and the remote instances is how you can say if you want. So the all-in-one deployment would have all in this one process: the shell integration, Tinkerforge integration, and the IRC connector. It's one process. It's a runnable jar that's just about 6 MB, so really small compared to Spring Boot. And it has no remote calls, so you can just attach a debugger and understand it the normal way. You don't have to do big monitoring setup like you do for microservices. There was a talk about microservices, and there was the question, how do you debugging in microservice? And the answer was, you don't. You can't debug microservices. You only put very good monitoring in place, hope that it covers what you need. I think that's a questionable thing if you have to maintain that system. So that's the smallest way. And you still have your nice container vessel. You can deploy that as this runnable jar. You put it in an application server. It's just one thing to control. It's easy. You have to automate everything at once. And then you can use a more microservice. You have super recovery system, which is used by all the newer systems like console uses Zookeeper in the back end. And you have several processes. Each have parts of your bundles, like the RSC connector in one, the T4 LCD display in the other, integration in another one. All publish their service to Zookeeper and detect the other service from there and communicate mode. And the nice thing is, it's exactly the same bundles before. Development, we just change our. It's not that easy in practice, but it's a nice idea. Yeah, basically you have some stuff, but you can now scale individual processes where you need them, but you don't have to put everything in separate microservices. You just use it where you. And this remote service is really small. It's just 300 and 800 kilobytes. If you need Zookeeper, that's all you need to start, and then you can add more complex transports if you want, like fast binary transport from Reddit, SOAP and REST and JMS using CXF DOI, but it's all built on the principle. But if you start that microservice way, beware of the operation issues. They don't go away just because we now use OSGi. If we have processes and communicate really, you still have to solve operations problems. So let's look into more of that. Hope it's readable. So let's start with a top-level project. The thing is, which is unusual in the OSGi world, especially when talking about bndtools, it's all built on Maven. The build is very familiar with who's using Maven. At this level, we have the one bundle for the API, one for the GoGo command, one for the RSC connector, one for Tinkerforge display. And then there is a separate packaging. So that's the extra overhead OSGi always. In Spring Boot, you just put together, and it has already some kind of packaging, but that makes it also inflexible. In OSGi, you just define your bundle. Packaging is a separate thing, but it also allows you to be flexible in the packaging. So one thing, this is the one process for all things. One is the packaging display, where I put the GoGo support and the Tinkerforge display. There is the IRC support, where I also have a GoGo integration, Camel IRC, and these two can then work together. There's this index project. This is what makes the connection to bndtools, which I use in that case. This needs kind of backing index. It's like Eclipse PDE, the platform, where you draw bundles from. And this index is also backed by a POM. So where do I have it? Basically, I list all dependencies I have, and these are all available as OSGi bundles. I can also reuse prepackaged indexes, like, for example, in RSRA, CXF OSGi, special POMs with bundles of the technology, and the goal is we buy building blocks for every technology, like Hibernate and RSJPA and everything that is a bit more complicated than a single bundle could have POMs, so it's easy to integrate, and you just add the POM for it, a bit like the start in Spring Boot. This makes it just a backing deployment. This is the index, basically a list of all the bundles, and then I drag over the top level dependencies that I want, my bundles and the things that I cannot figure out automatically, and then I click resolve, and bndtools gives me the full resolved list of bundles it needs to make a complete deployment out of that. So I think we cannot go into each implementation. It's all on GitHub, so you can try it out yourself. It's very simple. I just looked into the things like the chat listener is just this interface. Chat broker is how you send out. It's a declarative service component that has all listeners and sends the message using a parallel stream to all the listeners. So this is how you send out. You implement that to listen to messages. And for example, in the Gogo shell integration, I have the shell listener, which this is service admin, so normally it would be just add component, and with that interface, and when a message comes in, I print out console. Or when I command that is named chat send. If I type send and something, this thing out using the broker that it references here, and uses a chat message as a data transfer object. So it's simple stuff, and still pretty flexible. Because you can add new modules as you want, and they will all fit into this system. So let's start with this packaging. Have this BND bundle with our top level dependencies. We already saw how it's resolved, and now we can just run it or debug it. I use debugging now, so I can also bug into the code easily and see what it does, and just let it run here. So it connects to this Tinkerforge display. I already get such a message, Tinkerbot join, which comes from the IRC. I can type hi and should see this message here. I can scroll through the messages. When motion is detected, I see it as a message here. It just has a delay, so it's not always reacting. And also see it on the IRC message. So if I go again, yeah, now it sees the motion. So this is all in one process, but it's already implementing quite a lot of different technologies. I can also show the build. It's just a simple Maven build, also pretty quick. So this builds the individual modules, also deployments. So if I have packaging all deployment, and I have to stop it here, I can put it here. Also, this is exactly in Spring Boot. You have a runnable and get a pretty nice shell with that. That's the client shell. We have all these components. List bundles is one of the commands. As long as command is, as long as the command is not complete, it's red. If it's complete, it's blue, and can also have this see what is available. I can send a chat message. I see the shell, but I see the IRC. Also here on the Tinkerforge display. So that's the one process deployment. I'll see the micro. This is the other deployment. It's I should show how it looks like a bit. So this is the same application bundles, chat LCD, chat command, part of these. And in addition, it needs some RS bundles, like the Zookeeper to have remote discovery, the TCP provider, which is the first one. It's just over a socket. So serialization with Java serialization and the topology manager to manage all that. There is also a discovery command, which gives me this command endpoints. I now get a lot of errors because it doesn't find Zookeeper. So I have to use docker import up for Zookeeper, and my Zookeeper is now I can list endpoints. This is a command by RSA where I see I have locally one chat listener with shell listener and the LCD writer for the LCD display, but I don't have any integration. There is no Tinker bot here. Now I can start the other packaging, the IRC packaging, which provides IRC and the remote communication, and it should fit into the other system. So I see here that something comes up. Oh, that's Zookeeper. So endpoint, 4 endpoints. Now also see IRC connector and the shell listener on the other side. And now, if I some IRC, it should be detected. I see there are some people online. Can you send just something? So we see that on our shell. This process is not connected to IRC. It's just using remote service to talk to this other process, the IRC connection. So basically, that shows that you can scale process to the microservice as needed, but you don't have to go all the way from the start. I think that is the power of AI, really. So what I can't show because of the time is also have Docker files for the individual deployments, so I can compose to start all my different microservices in Docker, and could use Docker Swarm keys into the machines. It's fully cloud available like that. So let's get back to the talk. Yeah, that's good. So what we see is OSGi can scale from very small to very large, while traditional microservices using Spring Boot just go very large. They can't be one process. They can only go all the way microservices. And OSGi, we have the choice to small with a modular monolith, and then break out needs scaling, or where we have teams that go faster, and they can deploy on their own, and we still can hold that works together. But the small thing here, you start as you go, microservices have two problems then. So if you're unsure, I recommend to start with the modular monolith on one process, and then you decide about the packaging and deployment late if you do it well, and you can then deploy as fine granular as needed. So the idea is deploy coarse granular, ideally all in one process, and only split out stuff that really must be separate, because it is a lot of overhead, and you don't want to do that just hype or fun. Reading, there's some other talks, especially Millen is very good arguments. What is wrong with microservices? Look into before it starting with that. They will link to the OSGi chat example, and there is also in OSGi an example also in how you export a REST endpoint, user endpoint, which is quite easy to recreate. So I'll post this all on my Twitter account. So I also give it to the organizers of the conference, but you also will see it at the Twitter account Schneider Chris, and can look for the presentation as well as the code there. I will post it in a few minutes. So any questions? Actually, it took quite, because when I started, there was no even integration for bndtools. Help of Peter Greens, I actually wrote this in. Where is it? If you look at that, the missing piece kind of export from a file into the self-running jar resolve, all in the build. This was a bit complicated, and the other things was to get a nice working environment for OSGi that includes a remote service admin, but that was not that difficult. Once I got the setup with this index based on a POM and the integration with BND run into maven, it was not difficult anymore. And the thing is that if you want this RS, RSA, and SIGSA, you can just copy what I did, and it will not take you all too long for that. So I guess you can easily run and try out this and do your own stuff in a few hours. BND is always needed. BND is behind the maven, behind BND maven plugin. So whenever you create bundles, you have BND under the covers. Only if you use BDE, it's not BND. But I really would not recommend to go that way. So the nice thing basically is that I have OSGi settings here. I might want to tweak things. BND figures the things you want in your bundle on its own. So if you look into the jar and see in the manifest, you see the package, export package, it's all, for the most part, so you don't have to do many things on your own. That's one thing with BND, and the other thing is the setting up your runtime. You can do this with Apache Karaf at that point. If you want to go services, then it's this single runnable jar, and bndtools can provide this export. It also provides a nice functionality to put together your application from the top level bundles and resolve. So Karaf is better when you have something that is not easy to set with features. If you index the specs, what you want to achieve, and know things you need in the packaging, basically this is what you set up, properties, run system packages. These are a few things that are a little difficult to figure out. For example, get SIGSF running and stuff. There you will definitely need help. But apart from that, it's pretty easy to just draw together your top buttons and let it resolve.
One more last question. You mentioned something about modular using Zookeeper. Can you elaborate what is Zookeeper?
Basically, Zookeeper is. Yeah, I don't know. Basically, remote service app has different discovery protocols, Zookeeper, and one is discovery config. You just write a config where you properties that you not put on a service into the config file, and remote service admin then your proxy locally for remote service. So basically, you put I want to use SIGSF REST. I have this remote URL, and the proxy is created, and then the remote proxy is created for you without any external discovery.
Any more quick questions? Maybe half a minute. Okay, so we will put up presentations on the OSGi